Most of us were taught a simple story. That science was born a few centuries ago. That before equations, laboratories, and microscopes, humanity mostly guessed its way through the world. That the ancients were clever, but limited, imaginative, but uninformed. But that story doesn't survive scrutiny. Because long before science had names for its laws, ancient civilizations were already using them. They tracked the heavens with startling precision. They built structures so stable they still stand after thousands of years. They moved water, controlled sound, shaped light, and transformed materials without ever writing a single equation. They didn't call it physics. They didn't call it engineering. They didn't call it environmental science. They called it survival. And when you look closely, something unsettling emerges. What if science didn't suddenly appear in the modern age? What if it was rediscovered? Across Egypt, Mesopotamia, the Indus Valley, Mesoamerica, China, Greece, and Rome, people were quietly mastering principles we would only later formalize. Not through theory, but through observation, repetition, and memory passed across generations. In this journey, we're not chasing myths or legends. We're examining real principles that ancient cultures understood long before modern science caught up. Because history doesn't just hide forgotten empires. Sometimes, it hides forgotten intelligence. This is Ancient Odyssey. And this is where we begin to uncover the scientific principles the ancients understood before science did. Every night, the sky repeats a pattern. To us, it's beautiful. To the ancients, it was a system. In ancient Egypt, priests tracked the heliacal rising of Sirius to predict the Nile's annual flood, a matter of survival for the entire civilization. In Mesopotamia, Babylonian astronomers recorded planetary motions and eclipses with such accuracy that their data is still studied today. In Mesoamerica, the Maya built calendars so precise that they exceeded those used in Europe for centuries. These cultures didn't just admire the sky. They measured it. Stone monuments, temples, and ceremonial centers were aligned with solstices, equinoxes, and lunar cycles. Sunlight penetrated corridors on exact days of the year. Shadows fell where they were expected to fall, year after year. Without telescopes, without satellites, without modern mathematics, they understood that celestial movements were predictable, that the universe followed patterns, that time itself could be tracked by the heavens. Modern astronomy would later explain orbital mechanics and gravity, but the ancients had already mastered the effects, long before the causes were known. And once you realize that, a question naturally follows. If they could predict the sky so accurately, what else did they understand here on Earth? Because when we look down from the heavens, we encounter stone, arranged in ways that should not still exist. When you stand before an ancient monument, the first question isn't how impressive it looks. It's why it hasn't fallen. The pyramids of Egypt, Greek temples, Roman aqueducts, Incan stonework locked together without mortar, structures surviving earthquakes, erosion, and millennia of time. This wasn't luck. Ancient builders understood that weight doesn't just press downward, it travels. In Egypt, the pyramidal form distributed immense mass safely into the ground. In Greece and Rome, arches and columns redirected forces outward, allowing vast spaces to stand without collapse. They didn't speak of compression or load paths, but they built as if they knew them. Walls thickened at the base. Openings narrowed upward. Stones were shaped so pressure made structures tighter, not weaker. Across continents and centuries, the same solutions appeared, because the same physical rules applied everywhere. Modern engineering would later give these principles names. The ancients simply applied them. And once buildings reached the scale of cities, another challenge became unavoidable. Stone alone couldn't sustain life. Water had to be controlled. Water is life. But unmanaged, it is also destruction. In Mesopotamia, early civilizations dug canals to tame unpredictable rivers. In ancient Egypt, the Nile's floods were measured and directed to nourish fields rather than erase them. In the Indus Valley, cities like Mohenjo-Daro featured sophisticated drainage and water distribution systems. Across the ancient world, water was moved using nothing but gravity and precision. Slopes were calculated carefully enough to keep water flowing without erosion or stagnation. Reservoirs stored supply through dry seasons. Spillways prevented catastrophic flooding. This wasn't guesswork. A canal built wrong could destroy an entire settlement. These civilizations understood flow, pressure, and resistance, not in theory but in practice. Many of their systems worked for centuries. Some still do. And as populations grew, a new realization emerged. If water could sustain life, it could also spread disease. So cities had to be designed differently. Long before germs were understood, ancient people noticed patterns. In the Indus Valley, homes were connected to covered drains. Wastewater flowed away from living spaces. Toilets existed in private homes, thousands of years before similar systems appeared elsewhere. In ancient Rome, aqueducts delivered clean water while sewers carried waste away. Bathhouses were supplied and drained deliberately, not casually. This wasn't luxury. It was prevention. These societies observed that stagnant water and waste led to illness. So they separated clean from unclean. Streets were designed for drainage. Laws regulated sanitation. Modern public health would later explain bacteria and pathogens. But ancient cities were already applying the results. And as urban spaces became healthier, people began to notice something else about their environments. Sound. Sound is invisible, but it isn't random. In ancient Greece, theaters were shaped so a voice could carry effortlessly to the highest rows. In Rome, amphitheaters amplified sound without electronics. In ceremonial spaces across Mesoamerica, architecture enhanced rhythm and echo intentionally. These builders understood that shape mattered. Curves reflected sound. Angles reduced distortion. Materials amplified vibration. The results were too consistent to be accidental. They didn't know wave theory. They didn't need to. They tested, adjusted, and remembered what worked. Over time, acoustic knowledge became embedded in stone. And beneath sound, beneath architecture itself, lay something deeper. Proportion. Long before numbers were written down, they were felt. Ancient builders noticed that some shapes simply worked better than others. Certain proportions felt stable. Others felt balanced. Some inspired calm, while others inspired awe. Over time, these observations hardened into rules, passed down, repeated, and refined. What emerged was an intuitive understanding of geometry. Buildings followed consistent ratios. Walls, columns, and chambers were scaled in deliberate relation to one another. Distances weren't chosen at random. They were measured against the human body, the span of an arm, the pace of a step. Geometry became a language, one that translated space into order. These proportions weren't just aesthetic. They distributed weight evenly. They controlled light and airflow. They guided movement through a structure, shaping how people experience space without realizing why. Across civilizations, similar geometric patterns appear again and again. Circles, squares, triangles, combined in precise ways to create harmony and efficiency. Some ratios were repeated so consistently that it's clear they were intentional, not decorative coincidence. Modern mathematics would later explain why these proportions work, why certain ratios recur in nature, architecture, and design. But ancient cultures were already applying them, not as abstract theory, but as lived experience. They understood that the world could be measured, that space could be ordered, and that balance was not subjective, it was structural. And once geometry was mastered in stone, it became clear that buildings didn't exist in isolation. They existed in unstable environments, because the ground itself was not always still. For ancient builders, the earth was not a solid foundation. It moved, it shook, and sometimes it destroyed everything. Civilizations living along fault lines learned this lesson the hard way. When rigid structures cracked and collapsed, people noticed. When flexible ones survived, they remembered. Over time, a quiet understanding emerged. Buildings had to move with the earth, not fight it. Ancient engineers began separating stones instead of locking them rigidly together. They stacked blocks in interlocking patterns that could shift slightly without failing. Some foundations were layered, allowing movement to be absorbed rather than transferred upward. Walls were reinforced with alternating materials to prevent catastrophic cracking. These weren't lucky accidents. They were responses to repeated disaster. Without seismographs or equations, ancient builders recognized patterns, what toppled during earthquakes and what stayed standing. The surviving techniques spread, refined by experience and necessity. Modern earthquake engineering would eventually describe concepts like energy dissipation, flexibility, and base isolation. But centuries earlier, the ancients were already applying those ideas in stone and timber. They didn't eliminate earthquakes. They reduced their consequences. And as structures became more resilient, attention turned to another invisible force shaping human experience. Light. Not just illumination, but how it could be guided, framed, and controlled. Light does more than help us see. It shapes emotion. It marks time. It gives meaning to space. Ancient builders understood this instinctively. In ancient Egypt, temples were aligned so sunlight reached sacred chambers on specific days. At other times, those same spaces remained in shadow. Across the ancient world, openings were positioned deliberately, not for convenience but for alignment. This wasn't decoration. It was control. Ancient architects noticed how light entered openings, how it reflected off stone, and how angles determined brightness or darkness. Over generations, they learned to guide sunlight the way water was guided, by shaping its path. They narrowed corridors to concentrate light. They angled surfaces to reflect it deeper into rooms. Openings were positioned not for convenience, but for alignment with the sun's movement across the sky. Modern optics would later explain reflection, refraction, and angle of incidence. But ancient structures already demonstrated these principles, turning raw sunlight into a deliberate design tool. What's striking is how intentional it all feels. Light was used to signal moments, to emphasize importance, to connect human space with cosmic rhythm. And once builders mastered light, they turned their attention to something even more fundamental: the materials themselves. Because stone and wood could only go so far. But metal could be transformed. From Mesopotamia to China, ancient metallurgists learned that mixing metals produced new properties. Bronze was harder than copper. Certain alloys resisted corrosion. They didn't know atoms. They didn't know molecules. But they understood outcomes. Through repeated heating, cooling, hammering, and mixing, ancient smiths discovered precise methods that worked, methods passed down as guarded knowledge. Temperature mattered. Timing mattered. Ratios mattered. A small change could ruin the entire process. This wasn't accidental experimentation. It was controlled transformation. They learned that rapid cooling could harden metal, that slow cooling could make it workable again, that certain mixtures resisted corrosion better than others. Long before chemistry existed as a discipline, metallurgists were already practicing it. Modern materials science would later explain crystal structures, phase changes, and bonding. But ancient craftsmen had already mastered the effects, turning raw ore into tools that defined entire eras. And as materials became more advanced, civilizations began thinking beyond individual buildings or tools. They started shaping entire environments. Because survival wasn't just about strength. It was about adaptation. Civilizations don't exist in a vacuum. They exist in heat and cold, in wind and rain, in environments that can either sustain life or slowly wear it down. The ancients noticed this early. They observed how buildings trapped heat, or how they stayed cool even under harsh sun. They learned how wind moved through streets, how shade reduced exhaustion, and how vegetation altered temperature. Over time, these observations became deliberate design. Cities were oriented to catch cooling breezes or block harsh winds. Thick walls slowed heat transfer. Courtyards created airflow that lowered temperature naturally. Roofs, materials, and layouts worked together to regulate climate without a single machine. This wasn't comfort for comfort's sake. It was survival engineering. Ancient planners understood that environments could be shaped to reduce stress on the human body. They didn't fight nature directly. They worked with it, adapting structures to climate rather than forcing uniform designs everywhere. Modern environmental engineering would later formalize insulation, ventilation, and passive cooling. But ancient cities already demonstrated these principles at scale, quietly, efficiently, and sustainably. And when you step back and look at it all, the stars, the stone, the water, the sound, the light, the materials, the climate, something becomes clear. These weren't isolated insights. They were pieces of a larger understanding. One final question remains. What does all of this mean for us today? When we talk about progress, we imagine a straight line. But history is more like a circle. Again and again, we discover that what we consider modern understanding often rests on foundations laid thousands of years ago. Not by scientists in labs, but by observers, builders, planners, and craftsmen who watched the world carefully and learned from it. The ancients didn't have our tools, but they had patience, they had memory, and they had respect for patterns. They learned by living inside the systems we now study, such as gravity, water, sound, light, materials, and climate. And in many ways, they designed with more humility than we do today. The lesson isn't that ancient people were magically advanced. It's that intelligence doesn't belong to one era. It belongs to those who pay attention. And maybe the most important takeaway isn't what they knew, but how they knew it. Through observation, through adaptation, through working with nature instead of against it. If you enjoyed this journey into the forgotten knowledge of the past, take a moment to like the video. It helps this channel reach more curious minds. Subscribe to Ancient Odyssey for more stories where history meets possibility. And tell us in the comments, which ancient insight surprised you the most? Because the past isn't finished teaching us. We just have to listen.